This is a gigantic disclosure, and we think that it's a gigantic revelation. We have viewed Proxima Centauri b as an Earth-bound planet circling Proxima Centauri, which is the closest exoplanet we have found, since it's the closest star to the Sun. What the James Webb Telescope found that nobody expected was city lights in space, 7 trillion miles from Earth. This astonishing revelation has made people wonder if there is life on other planets. The telescope focused on Proxima Centauri b, which is the closest star to Earth, and showed that it was emitting unusually brilliant lights. What could be making these lights on Proxima Centauri b seem like city lights? Could this be an indication that there is life beyond Earth? Join us as we explore how the James Webb Telescope found these bizarre things in space. Researchers and people worldwide have been waiting and studying for years to catch a glimpse of life beyond our solar system. Any evidence that this space dream is true has been welcomed with great excitement. Researchers recently received the greatest shock of their lives when the James Webb Space Telescope detected strong evidence that there might be living things in space. The James Webb Space Telescope was exploring space and sending critical data back to Earth when it observed strange lights that appeared to be coming from the world Proxima Centauri b. These lights seemed to resemble a distant city's illumination. Researchers are stunned at the possibility of an alien city existing on this planet. All of them are puzzled because this discovery could mean that intelligent life forms in space are running societies that are entirely different from what humans know, and we're just now learning about them. When NASA specialists look at the city lights 7 trillion miles from Earth, they can't help but wonder how long these lights have been there, waiting for humanity to develop the technology to see them. David Kipping, a researcher at Columbia University, says that the Proxima B exoplanet is hard to understand because it has city lights. He noted that, due to the unique heating patterns in this star system, which are unlike those on other worlds, most rocky planets absorb sunlight and emit infrared energy. But this isn't true for Proxima Centauri b. Its infrared nature is completely different from that of its host star, Proxima Centauri. The James Webb Space Telescope was the ideal tool for this study, as its infrared imaging capabilities make it well-suited to capture these types of phenomena. The unique heat signature of Proxima Centauri b will help us learn a great deal about the atmosphere of other planets. Scientists hope to use the telescope to uncover more about the mysteries of Proxima Centauri b's atmosphere and to explore whether it might be possible to live on this extrasolar world. With its infrared sensitivity, the James Webb Telescope is ready to investigate what happens at night on Proxima Centauri b. While most space cameras struggle to detect the faintest beams of light in the vastness of space, the James Webb Telescope can capture even the slightest light emissions. It's the ideal instrument to determine whether the reports about city lights on Proxima b's night side are accurate. Any artificial lights in the universe can be detected by the telescope, as long as they fall within a frequency range much smaller than sunlight. The way Proxima's celestial features interact with its surface is fascinating. On the planet's day side, there are many solar screens collecting the star's energy, while its spectral edge reflects light back into space. When Proxima Centauri b completes its orbit around its host star, it experiences day and night cycles similar to those on Earth, with the sun warming it during the day and cooling it down at night. The planet's temperature is believed to vary depending on its composition. Without an atmosphere, Proxima Centauri b would have a significant temperature difference between day and night. If there were no oceans or atmospheric gases, the day side would be as hot as a black body, and the night side would be completely dark and frozen. Astronomers are deeply interested in studying the temperature variations to learn more about Proxima b's climate. The James Webb Space Telescope can swiftly analyze the planet's heat emissions, providing valuable information about its atmosphere thanks to its unmatched infrared imaging abilities. It's interesting that the James Webb Telescope's orbit around the Earth aligns with Proxima b's orbital period, which means its day and night cycles can be fully observed in 11.2 Earth days. Since Proxima Centauri b likely has an atmosphere, the next step is to study its atmospheric chemistry to assess its habitability. Gases like oxygen, water vapor, and methane are significant indicators of habitability. If these elements are found on the planet, it could imply that it has conditions suitable for life. However, researchers must carefully record and analyze light beams as they pass through the planet's atmosphere to understand this further. Though the James Webb Telescope is excellent at characterizing planetary atmospheres, it struggles to detect molecular oxygen, a crucial biomarker. Even with these challenges, the camera can still look for other atmospheric components like ozone, which also signals life. Another important aspect to consider is that the James Webb Space Telescope can observe a few of the closest potentially habitable worlds to Earth. Astronomers are eagerly awaiting the debut of ground-based telescopes like the Extremely Large Telescope (ELT), set to start operating in 2028, to conduct more in-depth studies of distant planetary atmospheres. The ELT will enable astronomers to gather even more detailed data on the atmospheres of faraway exoplanets. That will assist us with figuring out how tenable those universes may be. Yet, up to that point, the James Webb Space Telescope is still a significant tool for us to utilize as we attempt to understand what peculiar things occur on faraway exoplanets. Despite some issues, the Webb Telescope may still impact the way we contemplate exploring different planets, both now and in the future. The primary objective for future space telescopes is to eliminate the bright light that comes from a planet's star host. This will assist researchers in seeing the planet's faint light reflections more clearly. To do this, they intend to use internal masks or large external satellites that act like shields, similar to how you cover your eyes from the sun to see things better. Future telescopes will be able to study faint light reflections from distant exoplanets more effectively since host stars will emit less bright light. This will allow for a more in-depth study of their atmospheres and their potential to support life. However, this process has some challenges, such as the need to differentiate between gases produced by living organisms and gases created by natural processes, like volcanic activity. Astronomers are still determined to learn more about exoplanets and distinguish true signs of life from false ones. The Webb Telescope's work on exoplanets provides a sneak peek at the exciting discoveries still to come. As our exploration of space continues, we learn more about how the universe operates and our place within it. Scientists have been searching through space for a long time but haven't found concrete evidence of life beyond Earth. However, the search for other forms of life continues. People have been wondering for a long time if they are the only ones in this universe. Scientists use the James Webb Telescope to search for signs of life on other planets and potential hidden alien societies. This question has lingered for a long time. A common story suggests that aliens are waiting to be discovered among the stars. The Search for Extraterrestrial Intelligence (SETI) Institute was founded in 1984 by American scientists Jill Tarter and Thomas Pearson to explore this idea. SETI is a non-profit organization with the mission of searching the universe for radio messages from space. Radio waves are interesting because they can travel long distances without getting lost or absorbed, unlike some other forms of radiation. Although SETI has been searching for over 30 years, they have yet to detect any such signals. Jill Tarter, on the other hand, remains hopeful and believes that new technology will help accelerate the search. She thinks that new discoveries will be made if everyone on Earth can join in the search for alien friends in space. Likewise, NASA has recently suggested that the James Webb Space Telescope may have detected city lights from a world close to Earth. The JWST is an excellent tool for learning about the universe because it is designed to reveal details about galaxies, planets, stars, and the origins of space that are difficult to discover. With its powerful camera and filters, the telescope separates specific light wavelengths, allowing scientists to study the chemical and physical composition of distant celestial objects. The Webb Telescope is continuously searching for faint signs of life in the atmospheres of other worlds, helping us unlock some of the universe's most intriguing mysteries. One of these mysteries is the discovery of more mass in the universe than previously expected. This hidden mass, found in very large galaxies, makes us question the shape and size of the early universe. Just a few decades ago, we knew very little about the universe beyond our solar system, but astronomers have now discovered over 4,000 exoplanets orbiting distant stars. This shows the extent of our curiosity and technological capabilities. NASA believes that these discoveries are only the tip of the iceberg in terms of space exploration. According to scientists, there are likely trillions of undiscovered exoplanets out there. Researchers are still scanning space, hoping to find alien worlds where humans have never been. Along the way, there have been moments when the possibility of life seemed conceivable. For instance, when the Galileo spacecraft explored Jupiter, its spectroscopic equipment revealed a unique set of wavelengths that supported the idea of plants growing on other planets. Scientists detected a biosignature for the first time, indicating the possibility of life in the universe. Vegetation red edge was the name of this biosignature. The VRE detects alien life by closely examining how light reflects off objects. Using the VRE, the James Webb Space Telescope hopes to unravel the mysteries of extraterrestrial environments by carefully analyzing the orbital parameters of planets that may reside in the habitable zones of their alien parent stars. Once identified, the VRE can provide important clues in the search for intelligent life beyond Earth, initiating a new journey to learn more about the secrets of the universe. When sunlight passes through atmospheric layers, the molecules and particles in these layers absorb and scatter light, creating unique spectral patterns, much like fingerprints. As the absorption process continues, it's expected that the Webb telescope will capture light from stars as it interacts with the atmospheres of planets. Based on current knowledge, the JWST might be the missing piece in understanding the compositions of these planetary atmospheres. A significant amount of carbon dioxide, nitrogen, and oxygen is often found in the atmospheres of Earth-sized planets. Life could exist on these types of planets, but the absence of certain unusual chemicals might imply alternative forms of life or technological societies there. Chlorofluorocarbons, CFCs, man-made chemicals used for cooling and other industrial purposes, could potentially help scientists prove beyond reasonable doubt that advanced societies exist beyond our solar system. If the JWST detects these synthetic chemicals in the atmospheres of exoplanets, it would be a clear indication of life beyond our solar system. This presents astronomers with new possibilities to study the composition of other worlds' atmospheres and explore the slight chance that civilizations exist beyond the Milky Way. There are possibilities for life beyond Earth that current Earth-based science cannot explain. People often think of calm regions as life-supporting environments, but the reality may be harsher and more complex. For example, extremophiles, a rare group of organisms primarily composed of bacteria, challenge everything we think we know about where life can thrive. These resilient organisms easily survive and grow in environments that humans would consider extremely hostile. Extremophiles can live and thrive in places with temperatures as high as 250 degrees Fahrenheit and pH levels below 3. Their ability to endure harsh conditions is an extraordinary example of life's resilience. Because of the universe's vast size and variety of environments, our search for life remains a fascinating and ongoing journey. For life beyond Earth, expansive planets that resemble Earth and orbit stable stars like the Sun are extraordinary spots to study. Likewise, considering alternate ways to explore, like exoplanets near red dwarf stars, which are very common in the universe, opens up new areas to study. Red dwarfs aren't as bright as our Sun and are typically cooler. However, they give us a chance to explore the possibility of life in a wide range of settings. Red dwarf stars live for an extremely long time, which gives slow, complex evolutionary processes plenty of time to occur. The James Webb Space Telescope discovered a new planetary system called TRAPPIST-1, which is a significant new finding. The fact that the planets in this system seem to resemble Earth and could potentially support life is very intriguing. Planets in the TRAPPIST-1 system that resemble Earth are part of a planetary system composed of a faint red dwarf star and 7 rocky planets that orbit the star and are similar to Earth. Among these 7 planets, 3 have been found to be habitable, which means they are likely to have liquid water on their surfaces. Earth's sun is larger and hotter than the TRAPPIST-1 star, yet it emits a soft light similar to what we experience here on Earth. Researchers have looked carefully at the light from this star because it could help them find conditions that make the planet TRAPPIST-1 habitable. The JWST studied the entire system of planets and concluded that the red dwarf star is 41 light-years away, in the constellation Leo. Ward Howard, a NASA scientist and lead researcher at the University of Colorado Boulder, was excited about the finding. He said that the JWST made it possible for the first time in history to search for planets around other stars with atmospheres similar to our own. He also discussed how important it is to learn about exoplanet stars in order to learn about their planetary systems. There are a lot of stars in the universe. However, Proxima Centauri stands out because it is only 4.25 light-years from the Sun. It's the closest star to Earth, yet its light is so faint that you can barely see it at night. Because the star isn't very bright, any habitable planets that orbit it would need to be 20 times closer to Proxima Centauri than Earth is to the Sun for it to be livable. Astronomers made an interesting discovery on August 24, 2016, when they found a planet 1.3 times the mass of Earth that was in the habitable zone of Proxima Centauri. This Goldilocks region has just the right amount of light to melt ice into water and potentially develop life. The fact that Proxima B is an exoplanet that orbits its parent star, Proxima Centauri, is remarkable. Proxima B is only 4.6 million miles from its red dwarf star, yet it experiences a harsh environment that makes it challenging for life to survive. It is very close to the star, so strong solar winds could harm its atmosphere. Even with these issues, Proxima B receives enough sunlight to maintain Earth-like temperatures, which implies that liquid water could form there. Scientists have also observed tidal locking on the planet, meaning that one side is always in direct sunlight, while the other side is always in darkness, similar to the Moon's relationship with Earth. Proxima Centauri emits a faint glow that contrasts with what most would expect from a star of that size. Despite its challenges, Proxima B holds some interesting possibilities. If it has an atmosphere capable of retaining heat, liquid water could form on its surface, sparking a series of events that might make it feasible for life to exist there. Life could potentially start in water and evolve into creatures that live on land or in the air. However, Proxima B only receives 65% of Earth's solar energy, which makes it seem unlikely to support life. The planet's tidal locking also causes its temperature to vary greatly, from extremely hot during the day to freezing at night. Being so close to Proxima Centauri makes these harsh conditions even worse. Proxima B is exposed to intense solar winds, such as ultraviolet and X-rays, which can harm living organisms over time. Solar flares also send high-energy particles toward the planet. If Proxima B doesn't have a strong magnetic field like Earth does, it could lose its atmosphere, making it impossible for life to survive. Realistic models suggest that planets like Proxima B, which are tidally locked, are likely to have their atmospheres dissipate quickly, leaving volatile gases outside to freeze at night. Earth's atmosphere is replenished by volcanic activity, but Proxima B doesn't have similar ways to replenish its atmosphere. The mysteries of this extrasolar planet go beyond what we can see on the surface, suggesting there may be advanced alien societies due to the harsh conditions on Proxima B. It's possible that alien life forms, possibly extremophiles, could be surviving there. Researchers don't know much about Proxima B's volcanoes or magnetic field strength, but there's still a slight chance that life could exist in its atmosphere. Having oceans on Proxima B significantly improves the chances of life there and fuels our ongoing search for signs of advanced alien societies. Recently, there has been an increasing interest in finding alien life because some people think that advanced alien civilizations might have developed better technology to withstand Proxima B's harsh environment. Some experts believe these aliens may have placed large solar panels on the planet's day side to capture energy from the star and use it to light and heat the dark side. Since Proxima Centauri B was discovered, scientists have been eager to see if the planet crosses the face of its star, as observed from Earth. By measuring its transit, scientists could determine the planet's size, mass, and density, which would confirm that it's made of rocks and provide useful information about the materials on its surface. Despite the significant challenges in studying Proxima B, it's still crucial to find answers about this extrasolar planet. People will continue searching for other forms of life as long as they're interested in what lies beyond our solar system. Proxima Centauri also poses a challenge because it frequently flares, making it harder to study a habitable world like Proxima B. Fortunately, the James Webb Space Telescope avoids the range of these flares and captures important images and data about the universe that will be studied on Earth. What are your thoughts on the possibility of city lights on Proxima Centauri b, located 7 trillion miles from Earth? Let us know what you think in the comments. Don't forget to share, like, and follow for more exciting videos.